Hello everyone, I am Abhishek and today we are going to solve palindromic substring problem. So in the last video we have solved this problem using recursion and memoization, and today we'll be doing the bottom up approach using tabulation, and we will see if there is any other way also we can solve this problem. So let's get started. So first, as here we are using the gap method. So, and we will be doing this using bottom up approach with tabulation. I need to make my dp first. So s dot length, then we have our vector of vector int dp l, then vector of int l, and I am initializing this with 0. Then we will go in the gap method, like we will be having two things, two for loop, which will go I equals to 0, I less than l, I plus plus. Then we'll be having j equals I, j less than l, and j plus plus. And at this point, using the gap method, can we do it in this way? As we are using gap method, we and also in tabulation we require some initial condition, and initial condition we know that the single character, this one index, so index only index I, only index like 0, only index 1, only index 2 will be the palindrome, like a, like this abc, these all are palindrome. So this we can consider as initial conditions. So I don't think we can go in a row wise manner like we go earlier, because we need to have our initial conditions on each indexes for I equal to j. So the initial condition will be I equals j, and after that every time our I is lesser than j, so whenever our I is 0, our j can be 0, j can be 1, j can be 2. So this point is good enough, but it we cannot do it using row wise manner. So with row wise manner it can't be done. So here if I equals 0, j equals 2, so whenever we are getting some palindrome, if we are able to get some palindrome, we are going to the I plus 1 and j minus 1. So I plus 1 and j minus 1, we are getting to lower value. So before finding any bigger one, like bigger substring like a, we need to find the smaller one first, like this small a. Then every time, for every case, this should be we should follow a proper pattern for this. So let me have it in this way, as we are using the gap method. So I will first calculate, I will take lengthwise and I will first calculate here for only considering this single digit. Then I will consider only like 2 digits, then I will consider the third digit, then like that I will go to the n digit, the length of the string. So 0 to length of the string. So my initial conditions will be L equals 0 part, which is only single character, which we know that it's a palindrome. And after that we can consider for a double character, then triple character. If there is more character, we can consider that. So in that way, so like that, as we have three characters here, first we can consider the single character, then we can consider two character like A, B and B, C, and then after that we can consider A, B, C. So if we are considering single character, I it should be I equals this, and if we are considered double character, then it will be then a double character or three character or four character, then the starting point always will be I will be less than j only. But as we are going here in a tabulation way, so we can calculate the lengthwise. We can go to the length. We can go in a lengthwise. So int L equals to 1 and L is less than equals n, L plus plus. So I am going till n. Yes, I am considering length over here. Instead of length, let me give it n, so that I can give here L. Okay. And from here we need to traverse, we can traverse column wise or row wise. So first we are taking the length, and I will take I and j value as column and row, and I value will be the starting index of the character and j value will be the ending index of the character. So for the first case it will not matter whether I take the column or row, but from the succeeding cases, I can go column wise, but it will be better for me to take the starting index, so I will prefer to go row wise. So my row will be 0, then I is less than n and I plus plus. So why I less than n? Because we have index till 0 to n minus 1, and here we are calculating the length. And then my j value, I can calculate my j value here, with respect to I value whatever I have. I can go in a j part, so j value will be uh, so what should be our j? So j actually represents the length. So I plus j is equal to L. So as I plus j equals should be equals to L, and I can take here j equals to I. Let's have this way, I plus j equals L, but here it is plus 1 as I am taking the length, equal 1, so I need to increment the index by plus 1. So j would be whatever L value is there, L minus I minus 1. So length minus I minus 1 will give us the j value. So j equals L minus I minus 1. So L minus I. Is it correct? So length I am taking 1. So if I am going to the second index, so length will be 2. So if I go to this point, I equals 1, then my j should be equals 2, so it should be 2, so I is 1. Let me think a bit how I can like compute my j. So j should be equal to the total whatever I value is there, I plus the length, whatever length is there, minus 1. But my length is the j index, means the ending index, okay, ending index minus the starting index equals to length, but length should be minus 1 as I am taking from here. So index, whatever index we are doing the j minus I, we should minus 1 from here as I am starting the length from 1. Or else I can start my length from 0, so I don't need to do the minus. So it should be j equals L plus I. J equals L, okay, this is correct. L plus I we are doing, and minus 1 we are doing for the index matching, so that as we are taking L equals 1, so that thing we are just doing the minus 1, so that we can have a proper indexing. And then whenever I will be having I equals j, my dp would be ij equals true only. Else if my j index is adjacent to my I index, then at that case I will be doing dpij equals s of I equals s of j. Else if s of I equals s of j, then at this condition dp of ij equals dp of I minus 1, or not I minus 1, dp of I plus 1 as we are going to the next index, and j minus 1. If it's equals, else we will have our false case. So from here we can consider all the substring also, and on all the substring we can have our initial condition, and with respect to the initial condition we can compute all our palindromic substring. And whenever we got, I will have one more check here. Whenever we got the ij, then I will have count plus plus to count the number of palindromic substring. Int count, I will mark it 0, and at the end I will be returning count. I think everything seems perfect, and edge cases are also taken, and here edge cases are also taken care of. But what had happened? index overflow. Okay, one thing I have missed over here, because of which the index is overflowing, that for loop is there. So for loop we are going through all the rows. Correct, correct. So what will happen is like mm, we need to do here n minus l, and there should be equal to sign here. Now it should work. I will explain you now what actually the thing is, then I can submit. Let me submit it. Yeah, it's correct. So what was actually happening here is, as we are making a like 2D matrix, so in the 2D matrix, when I am going to the last row, so in the last row there should be only one case, which is the C case, the last index, only one character case. And then when I am moving to the n minus 1 row, there should be two cases, that is the B case and this BC. And when I am moving to one more case up, like this first cases, like first row, then there should be three cases, that is only A, then AB, then ABC. So what it is happening is, whenever we are going to the lower rows, like I plus 1 rows, so whenever we are going I plus 1 I plus 1, we are making our substring smaller and smaller. And whenever we are going above, like one above the row, we are making our substring larger and larger. So whenever we are going to the downward, so at the end of the row there should be only one condition for C. Correct, because I is at here and J can be at here only, and there is no other possible cases of J here. And then that's why I was doing here n minus L, and I put equal to sign, because here L itself I have defined 1. So L itself I have defined 1. So what will happen is, like, it will move from 0. In the first case it will move from 0 to n minus 1. So n minus 1 row we don't need to touch again. So in the next iteration L will become 2, and it will go to n minus 2,